Record. Okay, recording has started, and I'm going to share my screen. Okay. Awesome, Kip, you have the floor. Just let me know when to move forward.
Okay, cool. So first of all, I guess from the number of our participants, we're at about 10% of our the people that showed up on LinkedIn. So a little more intimate crowd, so that's nice. And then I guess more aviation type people than what I anticipated, but I'm still going to keep it fairly high level. And I'll just first start with a brief introduction of myself and how Amir and I met. So roughly 10 years ago, I did a lot of grassroots flight data monitoring kind of promotion stuff to initiate new programs. And so essentially building programs up in the rotorcraft world, non-scheduled fixed wing, so basically everywhere outside of the airlines. And so Amir and I connected in Vancouver. He was a room monitor, I believe, for me. And basically I followed him along for the past 10 years and followed his career a little bit. And so it's been a nice relationship, and I'm glad that he invited me. I'm glad that we can talk a little bit about flight data monitoring tonight. So I'm going to try to keep it a little, it won't be super technical. And I'll try not to throw in a bunch of acronyms like the typical aviation presentation. So, but feel free to ask questions. We have a small audience, so we can ask them, I guess, whenever. So I guess we can go to the next slide. Thanks. All right, so anyways, again, welcome to Tech Talk Vancouver. Again, I'm Kipp Lau. I am super passionate essentially about everything related to aviation, from flying to safety and technology. And so I get really excited where there's an intersection between any of those domains. So flight data monitoring kind of falls into a place that I've really enjoyed. But background as far as flying, I've been flying for 38 years now, mainly airliners, flown everything from Metroliners to 747s, currently an Airbus captain for a large package freighter company in the US. And as far as a safety expert, I touched a little bit on my kind of grassroots promotion of flight safety programs, primarily flight data monitoring. I got into other technology stuff such as the health usage monitoring systems for helicopters, TAWS systems, and other type things. And then in addition to all those things, I'm also an aviation journalist. I currently write for Aviation International News, and I've lost count, but I'm up somewhere around 300 articles or so. But as far as what's specific to this conversation, 20 plus years of flight data experience. And I've got the Canadian flag because I love about everything Canadian. I've worked in BC for Skytrack in Kelowna for about 3.5 or 4 years as a contractor, and then also worked for CAE in Ottawa. So, I believe there was somebody from Plain Science, maybe. So I know Mike Poole really well, but anyways. So tonight we'll talk about flight data monitoring, and we'll look a little bit beyond leveraging analytics from the safety perspective to more of a, we'll end up going down the path of efficiency. So using data and big data, as they call it, to simply solve some of the issues that we've come across in the airline world, and using data to, essentially make our lives easier or more efficient or save money. So really this is a discussion kind of beyond the black box. So everybody's familiar, especially since there was quite a few aviation folks in the audience, about the black box, which isn't really black, but that's where we get the data, or most of the data. And so we'll talk a little bit beyond that. So next slide, please. All right, so today we talked a little bit, so again, geared more non-aviation and maybe a little bit more slanted towards the tech side. So what we're going to look at tonight, and hopefully the presentation will probably take 20 minutes or so, and then we can open up the floor for a more meaningful conversation amongst each other. So we'll look at a brief overview of flight data monitoring, a little bit of the history. So flight data monitoring has been around 30, nearly 40 years now. Started with some of the European carriers essentially to validate auto landings using old recording technologies just to validate landings and how those aircraft would land on their own. After that, we'll talk a little bit about the data sources, so where the data comes from, the quality of that data, and the quantity of the data. So depending on the aircraft, there's a lot of different answers to those things. So either a little bit of data or a whole bunch of data now, and of various, I guess, forms of or measures of quality. Then we'll look a little bit into the processes and tools. Recently, my organization has transitioned to, or the gentleman from Ergos is on. So we are fully implemented now with Sarah, which is their new analysis tool. So the first 19 years of my life, I used a legacy tool. And I can tell you that our new tool is pretty fantastic. And so we'll actually talk a little bit about that down the road. Additionally, so, we'll kind of bring it full circle, talk some case studies, and then tell a couple stories of how we've improved safety and efficiencies. And then we'll open it up for questions. So next. So really, what is flight data monitoring? As most of you know, or the aviation folks know, that it is really grabbing data rather than looking at the accident flights, which are fewer and far between now. So it's not very meaningful to actually look at those accident flights because there's not that huge of a sample. So now flight data monitoring programs look at all those routine flights. So every single flight that's out there, we download the recorders, look, compare how the crews are flying to how they're trained. And then, so essentially it fits into what is in the modern safety world now, a safety management system, which is kind of the business approach to managing safety in aviation, and some other industries are doing that as well now. So we look at identifying, quantifying, assessing, and addressing those operational risks. So the stuff that flight data monitoring is really, really good at are identifying new risk or identifying ineffective risk controls that are in place. So we can talk about that stuff later on if you wish. And again, so these flight data monitoring programs, they're really intrinsically non-punitive. So that kind of opens up, the program at my carrier. We've had it for 20 years now. And it's to the point now that culturally, people get it. We're a gatekeeper, who are those pilots that do some of the analysis work. We have these things called a crew contact, or we're the only ones with access to identifiable information where we can reach out to a crew member to discuss a specific flight. But at our operation, we get almost an equal number now of what I call focal confessionals, where FDM confessionals, where the crew member reaches out to us to ask about a particular flight. And so now with our new tool, we're able to actually share animation and share data files with those crew members to kind of, it's a great learning tool to see how they're doing on their actual flights. And then beyond safety, operators now are really starting to leverage data and analytics to improve efficiency. So whether it's improving fuel usage, maintenance, reliability, airspace optimization, reliability and such. So big data is here, and the airlines and aviation, the operators are really starting to leverage that to make some really meaningful improvements to their operation. Next. So this is your typical flight recorder from a air transport airplane. I believe there's a gentleman from Teledyne. So they come in many different flavors. So Honeywell, Safran, L3, Teledyne, all make these devices. So it's pretty common. Most air carrier, or all air carriers, have those. most large transport or most large turbine powered transport aircraft now have some form of a flight data recorder. So which basically enables these flight data monitoring programs so you can leverage data to improve your operation. The easy way to get data off of those is to, in parallel, essentially there's a quick access recorder where there's some form of a media where you're able to extract that data from those recorders and then process it in the software that we'll talk about shortly. Outside of the air carrier world, I guess around the time when I met Amir was a lot of smaller companies started developing lightweight recorders for non-transport category airplanes, so for helicopters, lighter business jets and such. So, you know, Canada, there's Skytrack, Latitude, and then in the US, another company called Apario made these lightweight recorders, which, you know, 10 years ago, you think of confluences of technology that made that stuff possible were these small micro electromechanical sensors and, you know, things that are commonplace now like GPS or even the internet. If you go back 10, 12, 15 years, that stuff wasn't that common. So that's kind of where these lightweight recorders really kind of started taking hold, is when these other technologies started taking root to be common. So next. So we'll talk a little bit about data quantity and then quality. So we mentioned the recording devices. The amount of data that comes off of one of those recorders is really dependent on the, I guess, vintage of the aircraft and the type of recorder that's installed. The quality of those, the recorded data, which we call parameters, it varies. Older technology airplanes, I remember when I first started, it was fairly common to lose maybe about 20% of the data just because of bad recordings and such. And now, once you do actually get a file downloaded, they're all fairly reliable with just a few little glitches here and there. So next, please. So we talked a little bit about, you know, turbine-powered airplanes. What's amazing right now in general aviation is a lot of light aircraft actually have recording capabilities. So, you know, a real basic airplane like a Cessna Skyhawk, and that's my, where I went to school, Kent State, they have brand new Cessna 172s with Garmin G1000 equipment, and it's recordable. So records around 66 parameters or so at, you know, once every second. Comes in a CSV type file and can be processed using, you know, relatively simple software. So back in my consulting days, one of my early projects was to, for a similar flight school, process like 8,000 flight files from a large school in the US. And we had 0 bad flight files from that Garmin system. So it's super recorded super well. So if you think of those light aircraft, that there's some of them out there that are actually have really good recording capabilities. And then if you look to the right, for those familiar with Nolanor, which is based in Montreal. So if you look at the basic old technology 737s, those aircraft, you know, had fewer than 100 parameters. And so Nolanor has actually, with Skytrack, added to those capabilities by converting a lot of old analog generations or parameters into digital. So Nolanor has really advanced their FDM program by really, you know, on their own, improving the recording capability of their aircraft. So it's pretty cool stuff that they do with those aircraft. So next. And so this kind of brings us to kind of level set current day state of the art aircraft. So in St. John's, Cougar operates S-92s. And so those aircraft record hundreds of parameters super reliably, which enables Cougar to have, you know, a world-class flight data monitoring program. And it actually enables their business a bit because it's a requirement for their customers, which are predominantly oil and gas customers that require these FDM programs to allow their passengers to fly in their aircraft. So they have, Cougar does it for the right reason, but then also it helps their business case quite a bit. And then to the right is the 787. So that's kind of like the pinnacle of really, really good data. So you're now capturing, 4,000 to 5,000 parameters with a super good common data format that's easy to read. And, you can get a lot of information. So essentially the more parameters that are recorded from the aircraft, the more that you can actually do with that. Next. So we'll talk briefly, just big picture of the process. So, why are we doing this? So, essentially what we're doing is we're turning all of that data that's recorded on whatever aircraft into some type of information. So the software tools is what creates that information. So coming off the box, it's ones and O's or off the recorder. And then the software, either legacy or even these newer tools, create some really, really good information, either by triggering events or being able to kind of use that data to kind of free play mode to search for, answers of problems that you may have in your operation. And ultimately that information creates knowledge that you're able to push out to either your flight crews or to your maintenance providers or whoever. So essentially, big picture, you're turning that data into some kind of information which creates knowledge for your information, and then there's those improvements right off the bat. So next. So this is a little bit of a more granular look at how it's done. So we talked quite a bit about the actual recording devices. So then the flight data is retrieved off of the aircraft. When I started 20 years ago, it was predominantly pulling a card and sticking it in if you're familiar with our products, the next day air envelope, sending it from wherever back to Louisville, which is where I live and we're based. And so you'd have to wait a day, grab the card out of the envelope and then process it. Kind of the common thing is to all of our maintenance bases have a card reader, so it's electronically sent to us, and then that's how we process it further from there. Some of the newer aircraft, including some in our fleet, actually have wireless capability. So when the aircraft lands, it actually offloads the data automatically to be further analyzed. And then the next step is to review it. So that's where we start talking about the software. So whether it's the legacy software or newer software, that's where those powerful software tools slice and dice that data to come up with some meaningful things. And then as far as a routine process, most operators either report to the organization via either monthly or quarterly reports. And then again, like any kind of quality assurance process, it's repeated, so over and over. So every single flight, it goes through this same process, which anybody that's done the actual work, Amir and others, that when you're at home on the weekends or you're on vacation, that as those airplanes or helicopters continue to fly, they continue to collect data. And so it's a never-ending deal. So next.
Airplane analysis system.
Any questions at this point? Awesome. So anyway, so this is kind of like your traditional. So this is where I kind of like want to highlight the old versus new way of looking at flight data. So if you look at the guidance material in the US, they called any of these systems, the software systems, the flight data replay and analysis system. So that's kind of like the generic term. Vendors called them different things. So whether you're using Sajum or Safran or Teledyne or whoever, they've got their own commercial name for these things, but they're all essentially the same. They convert this data off of the recorder, which is often in some type of a proprietary format, into some kind of useful values. And then that software slices, dices, looks at that whole stream of flight data for these events using essentially some form of Boolean logic, with and or statements, to figure out what these events are going to be triggered. I have some examples on the next slide, but then also these tools also go further to assign based on the severity of the exceedance, we'll call it. They assign a severity level to each of those events, and then that's what accumulates in your database within these flight data monitoring programs. Next. So essentially, we've been doing this for nearly 3 decades of looking at these flight data for FDM events using that Boolean logic. And so the major limitation there is that you are kind of only looking for those exceedances or those bad things that happen, right? So if you're triggering an event to, a common thing within flight ops is to try to encourage your crews to have a stable approach. And so typically the level at which the carriers want their crews to be stable, meaning on the correct speed, the correct descent rate, correct configuration, whether it's gear or flaps, that target is usually around 1,000 feet. So a lot of events are based off of, at that 1,000 feet, you look at approach speed, or you look at configuration, or you look at, descent rate. And if you exceed any of those parameters that are in your guidance, then it triggers an event. But what you do miss by looking at only those bad events, you miss out on all those good. So we'll talk a little bit about that later. Another example, somewhat simple one, is a hard landing. So typically there's a maintenance manual limit to the max vertical G that an aircraft can do on landing. And so that's a simple, if the aircraft exceeds X value at landing for the vertical G, it'll trigger a hard landing. Long landing, very similar. Another simple programming event is you're looking at the aircraft touching down, beyond the desired touchdown point on the runway, typically at 3,000 feet, using GPS position or other lat long position, and then that would trigger a long landing event. But again, you're only looking at those events that are triggering either long, hard, or those approach speed type events. And really, to talk a little bit about legacy software, the limitation is that that's what those software packages did really well. And if you wanted to do anything outside of that, it created, or you had to do a lot of additional programming. And since those other type of events were not triggered, you'd have to reprocess all that historic data to come up with new type of event you wanted to look at. So limitations in our old system, and I'm glad Argos is on, because it's amazing with a cloud-based system how fast you can process old data, but we're limited to about 10,000 flights per day per computer in our office. So when we fly, 15,000 flights on my fleet alone. If you're going to look at any substantial amount of data, often what we would do is when you leave on a Friday, you would crank up the 3 computers in the office and let them reprocess old flight data over the weekend to come up with these new events. And so it was super cumbersome, not super efficient. So now when we talk about, next slide, please. When we talk about our new software, a lot of these things are actually thought through, and where in the old systems you would have to create these snapshots to look at what's going on at a certain point in time in a flight. These new software tools, and this is an example of Sarah by Argos, where it's capturing these particular parameters on every single flight, whether it's good or bad. And so you're able to look at an individual event and it compares itself to the historic data of all those flights previously captured. And that's where you see the little plus symbol left or right of average of those flights that are in the database. So it's a super simple way to look at a flight to see how it's scored. And this particular flight, I believe it's a 7-4. So as you can see, it landed with 37,000 pounds of fuel, which was a little light for the typical 7-4. And then the other one that's orange would be the average N1 on landing. So that looks a little bit light. However, that's where we have another story to tell later on, where we change procedures going from max reverse on a normal landing to idle reverse for reasons. So anyways, so that's a great way to look at an individual flight and see how it compares to other flights within your historic database. So another great tool. And you can, again, within each of those elements that are captured, you can report on those, you can compare them to each other and such. So it's super, super powerful. And to come up with, this simple presentation and legacy system, you may have your machines running all weekend, and hopefully you got it right when you program those events, and you would then have to export it into Excel and do all kinds of other things to come up with these type of answers. So that's kind of where this modern systems are going to make it easy and more information available on any given flight. Next, please. So this is an example I talked where you could compare those snapshots to other snapshots. So, where we talked prior about the predetermined programmed events, this is a different way to look at flight data. So you could actually look at, in this case, there's 48,000 flights during takeoff. So you're comparing the runway remaining on the left side at takeoff, and then the acceleration rate, which I'm sorry, I cut off on the bottom. So where you can see the big cluster of those 48,000 flights kind of grouped together, when you can start looking at those outliers, that's another way where, where we've had problems in the past of if you're, putting all of your chips into these predefined events, you might miss out on things like this. So, that's a challenge if you're not normally trying to look for those flights that have long takeoff rolls and not much runway remaining. This is a great way to look at it. And then you can actually drill into each little dot, and that's an individual flight file that will come up. So again, it's the Ergos tool, super, super powerful. So next, please. So we talked a little bit, and I've been maybe harping a little bit on the old systems, not to be too negative on them, but when you focus only on the negative, you miss out on those things that are going well. So in this case, this is 3 years of data on a particular fleet. So 166,000 flights. And so of those events that were triggered, we talked about stable approaches. So the 660 were unstable. So when you start looking at configuration and the altitude they configured, you can see that it's somewhat, the distribution's a little scattered. And so the average, when we looked at that, it was like 1,700 feet, and we're trying to have the airplane configured and on speed by 1,000 feet. So maybe that was a little too late to configure, but then you look at all those good flights on the right side. And so now you're looking at all but 660 of those flights over a 3-year period. And so you can see where it's more tightly correlated with the distribution. And you can see that the average altitude that those flights configured that were stable were about 100 feet higher than those that were unstable. So that's like when you start trying to communicate with a crew member, or a group of pilots, you can tell them, yeah, that was bad. But I think it's more powerful to tell them and give them cues of, yeah, if you're configured by, 1,800 feet, there's a really good likelihood that you'll be stable. So the new modern safety term, if anybody's a safety geek, is safety 2. So this is kind of looking at the good to tell a better story. And the analogy that I like about it is, or that I think kind of brings it home is, if you want to study marriage, you don't want to look at divorce. You want to look at those successful marriages and those outcomes versus those that ended poorly. So by looking at the good, you can actually see where those crews are more resilient and do a better job. Next. So this is a cool picture. So this is a 74400, not ours, but I grabbed this off of YouTube just to demonstrate what happens on a contaminated runway when the aircraft lands. So right side of the engine, so that would be the closest engine to you is number 3, and then the outboard one is number 4. And so this is on touchdown, an aircraft that goes into full reverse. So as you can see, the moisture that's on the runway from the number 3 engine is actually pushed out in front of it and then gets sucked into the outboard engine, which is the number 4 engine. So what we've found is that airplanes landing on these contaminated runways, especially in the wintertime, they chemically treat these runways with urea, which has been causing that number 4 on the other side of the aircraft, the number 1 engine, to prematurely have corrosion and not make time on the wing. So each of these engines are millions of dollars. And so when they don't make their overall times, that's brings the attention to the carrier quite a bit. So as a result, most 747 operators now, if able, the preference is to do idle reverse landings rather than this max reverse landing to prevent that moisture from being pushed out into the number 4 engine. So using flight data, next slide, please. So using flight data, so this whole study for us started before we implemented SARA. So each month we had a kind of a quality assurance report that we had to do. So we would have to reprocess all of that fleet's old data, which would take 2 days in time to do, and then another day and a half or so of slicing and dicing in Excel to come up with all these things that our operation and the engine manufacturer wanted to assure that we were doing. So once we implemented, actually before we implemented with SARA, we had them create these snapshots to capture all these data points during landing for us. So now on every single landing of our 747s, it actually generates this, and this is presented to our maintenance folks, flight ops, and then the engineering guys as a dashboard. So every single flight is uploaded into this new dashboard, and it's updated every time that they open this flight, and it's all automated, which requires essentially zero work from our office. So we saved, one person doing 2.5 or 3 days of work, and automated it using this new tool, which is pretty awesome. Next. I think I mentioned before the ability to share flights. So likewise, so it'd be interesting to get the impression of other vendors or anybody who's on the call as far as their thoughts on animation, levels of animation, the usefulness of it, sharing it with the flight crews and such. So what we do now, and this is actually one of my flights. I was coming out of Miami and actually had one of our analysts on the jump seat, but you can see on the left side where there's 1.785 Gs, that's us climbing through about 3,000 feet, flying through a thunderstorm. So turbulent for a short period of time, and then it's smoothed out. Just a good example of a vertical G spike. If you want to know how big it is, like that's one thing that pilots typically are really bad at, is determining, as an example, a hard landing of what is hard, because you don't know, and there's no indication in the airplane of what a high vertical G actually is. So to share this information with those crews is pretty impactful. But also, so we talked about crew contacts on those flights where there are exceedances, where a gatekeeper needs to reach out to a crew member. So we can actually now just share this whole flight file with that crew member. And it's a great teaching tool to go over the flight and the data within that flight and explain kind of what went wrong. And I mentioned our focal confessionals, so that's becoming more popular with us now. And so this is another great tool. So if a crew member was curious, what their speeds were at 500 feet, this is a great tool just to share and share that information with that crew member. So this kind of brings it to the end. Next slide, please. So we can open it up to questions now. Amir, do you have anything?
Well, thank you. That was insightful, especially, first of all, I learned a lot myself in terms of what's in the market now. And the other issue is that, as someone who was mostly focused on the rotary wing side,
Yeah,
potential, basically, I think there's potential for that side of the industry to capture the opportunity. But before we go to questions, I would like to ask the guests that joined us after to introduce themselves. Do you need the screen anymore, or I can just stop sharing? Okay. Awesome. So we had Sebastian. Can you introduce us to yourself? Tell us what you do and where you're contacting from, where you're calling in.
Yeah, hello to everyone. My name is Sebastian. I used to be FDM analyst for Avianca Airlines. Now I belong to General Electric, the aviation side.
Okay.
Nice. And are you, where are you calling from?
I'm calling from Mexico.
Nice. Thank you. And then we have Bill. Hi, Bill. Not sure if Bill can hear us.
Oh, yes. Can you hear me now?
Yes.
Oh, good. This is Bill Diaz. I'm in Pensacola, Florida. I'm a retired airline pilot, and I'm just, I know Kip from way back at Atlas Air a long time ago, 15 to 20 years ago. Hi, Kip. So I just thought I'd tune in and see what all the flight data stuff was about. It was great. Good, very good information. Thank you, Kip.
Cool. Thanks, Bill. Thanks for joining.
Thank you. And then we have Farzad.
Hi, Amir. Hi, everyone.
Hi.
I'm a program manager working at Mimic in Vancouver.
Awesome. And we have Zahra.
Hi, everybody. My name is Zara, and I'm a machine learning researcher at Oracle Labs. And thank you for your nice presentation, by the way.
Awesome. Thank you. Okay, the hands are up. I'll get, we do the first question, and then I have something else to talk about. But sorry, I mispronounced your name, but go ahead. The floor is yours.
That's okay. Thanks, Amir and Mr. Kipp Lau. That was a good presentation. It was insightful. Thanks for that. And then I am speaking from Bangalore, India. I'm the head of flight data services, working with this company for the last 10+ years. First question is, what are the latest trends in the flight data analysis using the artificial intelligence? Could you throw some light on that, please?
I'm sorry, can you repeat the question?
My question is, what are the latest trends in the flight data analysis using the latest technologies like artificial intelligence and machine learning?
Yeah. So So as far as the actual like focus of current flight data monitoring programs, I guess in the safety aspect is it's not really changed much in 10 years or so. It's you're looking at unstable approaches, you know, and in the US through IHST, so that all the airlines submit their data to a central clearinghouse and they analyze that. So common things, unstable approaches, TCAS events, GPWS type events. I don't know if that helps you, but that hasn't really changed much. But like, so we're seeing, and our operation is to look at other things, you know, like, so in the past, we haven't really done a great job at measuring long takeoffs. So, you know, so now that's kind of a focus for us. And that's a common in the one or air carrier world, a lot of long takeoff events based on either data input or errors or configuration type things.
Awesome.
Okay. Okay, thank you.
Thank you. So before we go to the next question, we have this tradition of doing a group photo, a virtual group photo. So if people who want to be in the photo, please turn on your cameras. I give a few seconds to everyone, and then we'll take the photo. All right, everyone ready? Sorry, 1 second. I'm just gonna. All right, everyone ready? 3, 2, and 1. Awesome. All right, actually, Kip, I'm glad this question came up in terms of artificial intelligence. I mean, I was actually, because Zahra is actually, her expertise is machine learning. I was thinking, like, what are the potentials for something like machine learning? I get that the industry is very slow when it comes to these fancy tools, but as someone who was actually started to studying them, I was like, wow, what if we get them to work, and what potentials it has?
Yes, that's actually exciting, and like where a lot of this stuff is going. So the kind of on a global thing, I mentioned the SIAS, so they do a lot of you know, it's through MITRE, which is a big government contractor in the US. So they do a lot of type machine learning. So not only do they capture flight data, but also crew member inputs. So like from our safety, the ASAP programs, which is where crew members submit written reports. And so they do a lot of text mining in that regard to find commonalities and such. And then, you know, in our new software tool, Amir, probably in your life of a FDM analyst, you would end up validating low severity events and medium severity events and high severity events. And so in our new world, we don't do that. So, which saves a lot of time. For the low and medium severity events, if they're, you know, initially when we would validate them as being a valid event, if it was met that criteria over a period of time, then the software automatically validates it. It works, it's good. And the way it's set up within our program, the high severity events are still manually reviewed. And we have an analyst that does that, but, you know, transitioning from our old world to our new world, that machine learning of validating those low and medium severity events has freed up his time to where now he's actually doing meaningful flight data analysis work instead of just clicking, if anybody's used Sagem, Control-I or Control-V to validate events. So it's refreshing for him, because he was, you know, each time, I don't know what software you used, Amir, but every event we timed it. We did a analysis for to justify the new purchase of our new software. Every time you'd open a new flight file, it would be at least 19 seconds between each individual event. So that spends a lot of time clicking, waiting for that flight file to open. And so it's pretty easy to start justifying things that do, you know, machine learning or things on their own.
Yeah, I mean, I'm not going to tell you on the record which software I use because I have strong words about it. But one more thing that I mean, in terms of stories, like one kind of a story that comes to my mind that I think it was, since it was in the news and it's kind of Canada related. I mean, to explain it to those who are not in the industry, like basically how FDM can help in such instances. Like it was a few years ago that the Air Canada flight from Toronto was landing at SFO, and it was mistakenly landing on the taxiway instead of the runway, and he rejected like the landing, and he did it go around and come back. So I of course that something like that it's going to be investigated by NTSB and other for safety reasons, but for the opportunities and the role of analysts in a near miss like this, maybe you can elaborate on that.
Yeah, so you know, so that's something we can do, like wrong surface landings or takeoffs. That's another, you've got the data, so you can monitor that type of stuff. So you know, that's another emphasis item here in the States is now every time I'm flying, when the pilot the pilot monitoring gets clearance to land, I have to look at the nav display and verify that that's the correct piece of concrete I'm going to land on. So that kind of came from that San Francisco event. But you know, certainly something that we can look at with our flight data. We've actually, so say for instance that, you know, not only in the industry that not only the wrong piece of concrete being a taxiway, but there's been those cases where they've actually landed at the wrong airport. So I mean, that would be a pretty easy one to pick up with flight data in other ways. So certainly another thing to look at, you know, with flight data. But if you're recording the data, it's, you know, it's almost endless of what you can start monitoring. So.
Yeah. So, right. Next person, I think we don't have any hands up. If you want to go, you can go now. But if not, one more thing that it's not a question, but before the end of the meeting, maybe something to think of is what should be our takeaway in your opinion? And you don't have to answer it now, but
yeah, so I wrote down some stuff like leading up, so I actually obviously didn't read them off. But so really the big takeaway for this in my mind is, you know, modern tools, one, make your job easier, but then allow you to focus not only on the bad, but those good things. So the ability to using modern tools. So not, you know, like now with SMS, when I'm in the office doing my focal work, we have every fleet has a monthly meeting that we attend, and then the airline has a big meeting every month. So for us, it's 5 meetings a month, and now we're doing it via Zoom. So I have access to my computer, and when they have questions on the fly, I can, what used to take, you know, you'd respectfully ask for a data request, and then weeks later you could give them an answer. Now on the fly, you can use this cloud-based tool and come up with answers. So, you know, it's like, give me a second and it's done, which is pretty amazing. So really that's the takeaway of one, don't be focused only on the negative. There's more to learn from the good, right? So that example of unstable approaches of when to configure, if, and it's across the fleets of, you know, it's kind of like a well-done thing, but if you configure earlier, you're going to be stable earlier type thing. So that's pretty powerful when you can communicate that with the crews.
Awesome. All right. Nobody has their hand up. Just jump in. Feel free to jump in. There's no issue, but I mean, I have a lot of questions myself, but
yeah, sure. But
the chat, I want to give opportunity, especially as we have folks connecting from different places.
yeah.
And actually, you had some. You brought up examples from each of from some of the companies that are represented here. Maybe I guess it's the opportunity that you ask them questions.
Right. Well, I mean, I guess in general, since there's a lot of people that do what we do, right? So what are challenges? How can we fix those challenges? What are your frustrations? You know, it's pretty endless for those that are in the business. So
Yeah.
anybody?
Yeah, may I come in, please?
Go for it.
Yeah. Okay. One of the issue that we often face in the flight data analysis is the availability of the correct data frames for a particular type of airplane, especially the legacy kind of planes, where you don't really get to use the right data frames. So I think there was a discussion about this in the international community where the OEMs can upload the correct data frame, wherein whenever we download the FDR data, the correct data frame also should get downloaded along with that, so that the vendor does not have any issues when you actually convert the data. So this is one of the gray areas in the flight data analysis, lack of correct data frames sometimes.
So that's again, oops, am I on?
Yep.
Yep. So that's again, you know, real software dependent type question, at least in my experience. I've used either through consulting or in real life a number of different tools. Some are good at, you know, fixing that problem. Some aren't, but current state, if you have a really good vendor, they'll help you sort that out. But I do know, like, frustration from our legacy software was data frames, you know, so you may have 2 different or 3 different data frames for a particular aircraft type. And then a lot of times if you're searching parameters or other things, you have to be in that correct data frame. So the software wasn't easy to do that. Now, fortunately, our really good vendor has helped us out with that.
Yeah, eventually we fall back to the aircraft operator to give us the right data frames, because many a times the vendor will not be in the right position to approach either the OEM or the FDR manufacturing company to get this document. So
Right.
mostly we fall back to the operator to get the right information.
Yes. So, okay. So you work for a third party that does flight data analysis. Is that right?
Yeah. So I'm from Nest Group of companies. So we do provide the data analysis to the various general aviation as well as the airlines.
Okay, great. Yeah, and that's some of my consulting business. So that's a trick, is one, to get the right data frame, and then two, often to have the manufacturer give that up without having to pay for it. So it's, you know, like a Gulfstream, for instance, they consider it proprietary. So, you know, it'll cost you money to get the data frame or the LFL to read it properly. So anyway, any way you skin it, it's going to cost. So yeah, so those are frustrations.
Yeah, correct. Yeah. Thank you.
Yep.
Thank you. Actually, Kip, yourself and Bill, you guys are both pilots, and if there's any other pilots on the call, please jump in. I mean, for fixed wing world, when we first had the FDM started, of course there were challenges, but of course it's more established. There is acceptance for it. People don't have the initial skepticism, or they could manage it. And it's also part of the, for unionized operations, is part of the collective agreement. So, but for me, like, it can't be just the government regulation that could bring that acceptance. It should be something more. Like, I don't want to I don't want to date. I don't want to, like, consider any of you being too old for this, but in terms of knowing all the history firsthand. But I don't know, what do you remember when this thing about the early days of the FDM and what did it take to get pilots to accept it?
Yeah, so I don't know, Bill, if you can share any experiences.
Well, I don't know that much about FDM because I've been retired for a number of years now, but I was going to ask you, Kip, we've had flight data recorders around for centuries. I mean, it seems like, decades anyway. I don't want to go back that far. But do you see management or certain operators using the data in a negative way to chastise certain pilots or crews for anything they may have done?
Yeah, so I mean, I think that kind of goes hand in hand with Amir's question a little bit is, so one, acceptance of the crew members for these programs, but then two, to have management play by the rules and not use it in a negative way. So in my experience at my operator, that's all I know. I've done, my 20 years here, I've done FOQA for 19 of those years. And, our program just turned 20, so I've been involved with it all but 1 year. And early on, it was for the crew members for the buy-in, a lot of education, a lot of bombard them with information, a lot of, just going through the night sort, sitting there answering questions. But, so certainly the union had to buy into it also, which they did, but we've had really no resistance. There was those crew members who, thought that there was the potential to be targeted, for taxi speeds or whatever event, so we call them the tinfoil crowd, where they'd want the tinfoil over their heads to prevent us from looking at things. But, the reality is when you fly with those guys that think that way is, and anybody that's done this work is, there's thousands of flights that are flown each day and thousands of events that are triggered that you have to manage. You're not going to have time to look at an individual crew member. So that's one thing. I've not seen any abuse of flight data because it's in our contract that they can't use data in a negative way. And that's kind of starting to extend. As an example, Southwest has an overarching data policy for all of their employees. Because now, if you think about things that are recorded, it's not only flight recorders, it's, the non-volatile memoranda, FMC or GPWS or whatever. There's a lot of data that's available, not only on the aircraft, but now stuff that, ATC is recording or other people are recording that could be used negatively. So the trend is to have agreements that protect crew members and even other employee groups. Like Southwest, it includes all of their employee groups to include mechanics and stuff. So if they're taxiing an aircraft and have a mishap, that data can't be used against them. So the idea is to use the data in a constructive way, but not in a punitive way. And once in my 19 years here, we've had the government overstep, but that was solved quickly with the FAA. And so when you're able to bring them to, bring it to ground and tell them that there's far more benefits to the program than not having a program. And if they overstep, then there's the risk of losing those programs, then they understand that. So.
If I may add something, and I don't know the size of the operation that Bill worked on, but actually in your talk, Kip, back in Vancouver at the Safety and Quality Summit, there was someone there from a larger helicopter operator. I'm not going to name the company. Okay. And I had a chat there. I was just the coordinator there, and we had a chat, and he said that his FSO would fire people for a level 3 event. And I was like, what? No, what the hell? And this was one thing that I was like, wow, this was not a small operator. And the other one was an example that I faced myself. That's the
Mhm.
crew rep came to me, even though that was not my approach, but the crew rep came to me and said they were not really cooperative. And I mean, I used some cultural understanding to connect with them. And the guy was like, you know what? We look at you as the third man in the cockpit. And this was a helicopter operation. So you look above our shoulder. I'm like, well, no, that's not what I do. But anyway, so it's, I mean, in fixed wing world, I guess that's the point that I was trying to make is, I guess it's maybe it's light years ahead. I don't know.
Yeah, well, I mean, and that's, you know, like part of my time doing those grassroots conversations where I met you is, you know, at the time there was a large OGP company that their aviation advisors were any medium or high severity event, they wanted that crew to be contacted within 24 hours on each of those events. You know, and that's where that, in my mind, is a little excessive, you know, where we have somewhat limited conversation, you know, like, you know, I try to teach our gatekeepers who actually touch the crew members is, you know, one, if you're going to make a crew contact, what are you actually going to get out of it? You know, and so just have an outcome in your mind of what you're going to accomplish if you're going to make that effort. And it's truly not, you know, and there's certainly a lot of calibration that's involved. So sometimes a gatekeeper will, in their own mind, think that they are the police officer in the intersection, you know, and they think that they're going to affect, you know, behavioral change because they're there and they're going to call crew members. And it's like, no, that's not the point. You know, we're trying to find more information. And even now, you know, like talking about data is that we're using human factors type, you know, we're trying to collect more information from the call. And so, you know, I open it up with, you know, I'm going to learn as much as you're going to learn from this conversation. You know, so I can learn a lot more talking to a crew member of more of the root cause of what got them there than just by spouting off and saying, you know, trying to put the, you know, the hat on of being judgmental type thing. So
True. But the other thing is that, like, when you're talking about a larger operator with tens of thousands of flights a day and, you know, a lot of resources to build that trust. But when it comes to like small operators with, I don't know, maybe 5 or 6 aircraft, and again, I'm sorry, my focus is always on rotary wing, but it's just you know, it's a different mindset, that, and the structures are not as, you know, concrete. What is your opinion on that?
yeah, so it's you know, it's a tougher thing to you know, at a big airline, you're lost in the numbers, right? So I have no idea which crew members I've contacted. We don't keep a record of it. I may have talked to a guy twice, who knows, but in 19 years, I'm not going to remember that. You know, we have 3,000 pilots, but an operation where you have 6 crew members or 6 aircraft, it's going to be harder to separate that. And then I think the challenge too is, you know, if you're sharing information without people outside of your FDM program, it's easy to, you know, figure out, if you're a small operator, the flight that went from Vancouver to Kelowna, you know, if you only do that once every other week. And now somebody else is looking at that flight that went to Kelowna and did something, you know, poor, then it's pretty easy to track who did that flight. So we have the benefit of you know, being able to, it's lost in the numbers almost. And we actually, like for our reporting, the level of detail, we have a number of flights to a given airport before we'll report unstable approaches there, as an example, because we do a lot of military charters. So that one flight that goes to Wright Pat that month, and if it ends up being unstable, and if you report that month of that flight, one flight being unstable, they pretty much know who it is, right? So, so there's some trick there. Smaller operations, as you mentioned, a lot of operators. I did some stuff for HAI. So the number that has astonished me was 80% of the helicopter operators had 5 aircraft or less. So how do you, of people, the data people in the crowd, that's really hard to report and make that actionable information if you have that low, low statistical amount of flights. So my recommendation was always with the smaller operators on the way to start programs is rather than report monthly, you might want to report quarterly type thing. So you stretch it out so you lose that statistical variance of the very few flights or very few triggered events type thing over a period of time. So
Awesome. Thank you. Ashish, floor is yours.
Hi, just to add something to Captain's comment. Most of the time, like Captain mentioned, sometimes the government and the I will say the regulatory authority, they puts in certain conditions so that the crew has to be notified sometimes of events. So for example, they have set of standard events and it's a regulatory requirement that the crew has to be notified that this thing happened. So it's good and bad. Sometimes they get acknowledged that they didn't know that this happens. It's good in that way, and some people don't like to be bothered for small things. So that's one point which I would like to add. Sometimes it's the regulatory authority which makes it mandatory that the crew has to be notified. So that's one thing. And one more thing, just to add a previous discussion we had, Mr. Subramaniam, he asked about the data frames, difficulty in this. Yeah, it's very hard to get these data frames, and like Captain added, it's a proprietary information for some people, and it's a good way to make money for software companies because they did a lot of work on the configuration. So I'm not sure when that's gonna get set with the old data frames, but most of the guys know. For example, the new ones like 787, they have a FRED file which usually comes with the download. So that's actually so this is just happening in few of the data types like 787 and anything with an airing 767 data. So they have the config file that comes with the download. So it's pretty easy for the user to get that. I'm just adding a point. Thank you.
that's great.
Thank you, Ashish. Fernando?
Yes, good evening again to all of you. I want to make a comment on the last issue that was about the government instances. What's going on with the FDM? Here in Mexico, now in January, about a month and a half, not more than that, they made it mandatory for all what is ICAO and X6, what is airplanes with 27 tons and above. So they're looking at to do it to the corporate ones and the rotary as well. So that's pretty good to know about that. Now, in the other sense, what they were talking about if it's negative issue or not, well, even though the program it's a non-punitive, I have been working with Rotary Wing here in Mexico for about probably a couple of years, 3 years from now, implementing all systems for oil and gas companies. And I'll let you know that nobody's doing that. Everybody's working fine. Everybody's working and taking into consideration so what it's the events and making a proactive way to keep the flight safety in order. So we believe in here, and I believe in all the world is doing, and it's enhancing the FDM program in order to do that. I used to work with Ergas as well, and the company in Mexico for airliner jets. And it's a big, huge company. I know they're doing a pretty good job for this. So I believe everybody's doing a good job for everything around the world for FDM. So that was my opinion and my comment on this.
That's awesome. Thanks, Bert.
Thank you.
Yeah.
Awesome. Sorry, go ahead.
Oh, that's okay. So I was curious first. So you mentioned oil and gas, and so like I've been away from doing consulting stuff in that segment for a number of years, but call it 5 years. But often the advisors, in my mind, didn't, and maybe ran into this, Amir, but they really didn't know what to look for, like in an FDM program. So they would, you're basically, as they do the audits, they're, when do you have an FDM program? And rather than, what are you doing with the FDM program? Like, it seemed like, so in your mind, is their knowledge level getting better? As far as like the advisors?
Yes, I believe so, because the companies as well are making a lot of efforts to implement LVMs in here. And I know that in all over the world, in the States and Canada for sure. So that's what we're thinking, that it's not getting behind, it's getting forward with this. And as well, as you know, with IOGP and all these standards, recommended practices for FDM, they're trying to look at them and try to follow them to avoid what kind of incidents or accidents at the end.
Yeah, that's good.
Awesome. One other question I had, but I forgot. It was, the regulators and the consultants, advisors. I mean, a lot of times it just feels that the regulator, I mean, again, my examples are Rotary Wing, but they're just, I mean, I'm trying to be very diplomatic here, but it just feels like they're, and my former boss used to say, they just don't get it.
Right.
I don't want to be as black and white, but it feels like they're behind, and in like different jurisdictions, they of course it's different, but it seems that like FAA especially, like they're not really quick when they respond to changes.
Mm-hmm. Yeah. Yeah, we see that here, and it's this is kind of a global thing, right? We have people from a number of countries here, and probably if you were to ask how the regulator treated FDM, everybody would have a little bit of a different answer. So there's certainly not a global standard of how people do things, and it's interesting. Like, so our, the office that manages our certificate, it's I think they get what we do, but I'm not convinced all the time. We'll sit through quarterly meetings, and sometimes the questions that come out of their mouth, as far as when we're doing our report or our presentation, is a little astounding. So,
wow.
Or they focus on a single thing, and like, so so with our new tool, like, we can do a better job statistically at looking at things, so using standard deviations and such. And what drives me nuts is for other operators too, is when they focus on a single quarter of a negative trend. When they see that, they want some type of action, the government or the FAA in our case, but then often it could be seasonal, so for us, traditionally the fourth quarter is horrible because of higher winds and worse weather, and for us, a higher frequency of operation and things like that. And so you're going to see that rise, and then they want you to do something to change it. But like clockwork, January gets better, and February gets better, and March gets better. And it's like every year, but they focus on just that one limited time frame. So I don't know how to make them get off of that. So I don't know if anybody else has seen that either.
But Kip, the bigger question sometimes is like, because if we just focus on numbers and don't really see the context and
Mhm.
the story that they tell. I mean, what is like, because a lot of times the term FDM, it gets bastardized, and just getting some data and some diagrams without knowing the context, just it doesn't mean anything.
Right.
So,
Right.
I mean, I mean, at least that's how I see the role of analyst because those charts and those graphs and standard deviations, those calculations, the computer can do it better than any human being, no question asked. But the analyst is the person who gives that context and to give you qualitative analysis. And
Yes. Yeah, so you can tell that story.
yeah, and do you see, like, I mean, in this world that we always look at numbers and graphs, what does the future hold for the analyst? Like, do we even need analysts if we get into some fancy machine learning AI thing?
I think there's always, you have to combine it, right, with other things. So I think you can be tripped up if you don't have that human element, right? So if you don't have that knowledge of the fourth quarter stinking every fourth quarter, then you'll start chasing things. So, if you just look at the data, or, another popular term for OGP or managers that really don't get it are, these KPIs. And so they set some limit of, this is our, key performance indicator for this quarter, and this is what we want to do, and blah, blah, blah. But the reality is that, the world changes and everything changes. And so to be able to, rather than use a fixed number, have something more meaningful statistically is probably better.
Yeah, and I was about to say something else. Yeah, like one contextual example that I saw, it wasn't really about. Oh, actually, somebody raised their hand. I'm sorry.
Oh.
Yeah, Argos Chen, please go.
Oh, sorry, I'm in the car in the garage, so the light is not very good. And yes, that I would like to say, as the not only flight data analysis, the most important thing is to communicate with the all stakeholder to know that actually KPI chart or a statistic or even the flight data recording itself just part of story, and we don't even know the story is correct or not. So the only thing we can do is just to try to gather a lot of resource and information together and try to say that, okay, well, we like to know what is the trend and what is the main goal of the monitoring of itself. Otherwise, that we are not only challenged by the pilot group, we lose the trust from pilot groups or even other stakeholders. And that's just one of the comments I want to speak out and share with you.
Yeah, it's a great point. So you're stuck in the garage with poor lighting, and then my bald head keeps on grabbing a light that.
That's dedication, I would say, from both of you. But one thing, like an example that I would add, it was not time related, it was location related. So I was looking at this high speed landing or something. I forgot the actual event. So a high rate of descent on landing. It was just from one side of like one runway.
Okay.
And after that was the same crew that fought of me as the third man in the cockpit. So after a little while, I was like, what's the deal with this? Like, dude, this is just, it doesn't make sense. You're doing it right from the other side. And I, like, geographically looking at it on Google Earth and whatnot, I can't really understand. And I was like, well, you know what? We have an altitude restriction on the other side of this airport. Okay. This is like, basically, it's as simple as having a shady neighborhood where they shoot the aircraft. So when they get close to the airport, when they approach from that side, they have to just land as fast as possible. And he sent me reports with like bullets that they found while inspecting the airframe, and they're like, they shot the aircraft. So that's scary. Like,
Yeah.
it can be as simple as that.
Right. Yeah. But without you talking to the crew, you wouldn't know that, right? So a machine could never tell you that story. So, oh, and like what we find too is a good example are, you know, sometimes, you know, like that chart I showed you of the, you know, not very much runway remaining on the takeoff, right? So you can drill into that one dot, but then sometimes the machine will pick up, based on, you know, lat long, it'll pick up the wrong runway. So without the human interaction of knowing that we never use that runway, or that's not a thing, then there's, you know, that could be like a alarming thing where you're kind of chasing down the wrong hole if you know that it grabbed the wrong runway type thing. So that's one example. Or the simple thing of NOTAMs, right? So it displays threshold, and without the human looking at that NOTAM for part of the runway being closed, you might trigger a bunch of long landing events and start reporting on those. So you know, to Chin's point, you have to use other data sources, or, you know, you end up kind of flawed. So,
Exactly. So
cool.
go ahead. Sorry.
Nope,
Somebody
I'm good.
else? Yeah. Sorry, I thought somebody else was speaking. Yeah. Yeah. I think for at least I kind of think that after this turn of events for the industry, maybe there's still job security for analysts and for those who work in the FDM sector. And yeah, thank you so much, Kip. That was very informative, and thank you all for joining us from different regions. This event was recorded, so we're gonna upload it on YouTube and probably on LinkedIn. Mohsen, if I'm am I right?
No, we can't. LinkedIn just lets us have 10-minute videos, so just YouTube and Facebook.
Okay, yeah, just YouTube and Facebook. But thank you so much for coming. And if there's any final word for it from anyone, including you, Kip, please go for it.
Thank you for hosting this, and thanks to everybody who showed up.
Yep, everyone stay safe for the next few months. Grace on, and I hope that we can finally get together in person. Yeah, have a good evening, day, noon, wherever you are. Take care.
Thanks so much.
Take care, everybody. Thank you to everybody.
Bye.